Welcome to today's webinar, Drones Meet Computer Vision for Geospatial Insights. I'm Juan Ferlin, Marketing Manager at imagevision.ai, and it's a pleasure to have you all with us. Today, we'll be looking at how drones, powered by computer vision, are helping industries gain precise geospatial data and improve decision-making. Whether you work in agriculture, real estate, oil and gas, or construction, there's something valuable here for you. So before we start, just a quick reminder. If you have any questions, please feel free to drop in the chat at any time. Our expert panel will address them during the Q&A session at the end, so don't hold back. This session is being recorded, so if you want to revisit anything we will discuss today, you'll have access to it afterward. And lastly, to keep things running smoothly, everyone's microphone will remain muted during the presentations. But don't worry, once we hit the Q&A, we'll open things up for you to jump in with your questions. So today's webinar is a collaborative discussion with our partners at Marvel Geospatial Solutions. And we're excited to have Ravi, Vice President at Marvel Geospatial, joining us. Marvel Geospatial Solution is a leader in geospatial technology, offering solutions that span drone technology, geographic information system, GIS, and geospatial data analysis. Their work plays a crucial role in transforming industries like forestry, smart cities, construction, and energy with actionable insights derived from accurate and timely geospatial data. Our partner with Marvel Geospatial has allowed us to combine their geospatial expertise with our computer vision technology, enabling advanced real-time data analysis for geospatial applications. Together, we've successfully deployed solutions that improve everything from surveying and land use analysis to asset inspection and environmental monitoring. At imagevision.ai, our core mission is to empower businesses with computer vision, it's also known as Vision AI solution, for smarter decision-making. We harness the capabilities of computer vision technology to boost industries by achieving unprecedented levels of automation, accuracy, and productivity. It's not just about staying competitive in this digital era. It's about redefining how businesses they operate and succeed. We're also proud to be recognized by CIO Tech Outlook as one of the top 10 most promising computer vision startup for 2024. Our solution landscape spans across various industries, including packaging, bottling, FMCG, transportation, healthcare, pharmaceutical, security and surveillance, and the oil and gas industry. Our commitment is first and foremost to our customers. We're dedicated to delivering reliable, scalable computer vision solutions that exceed customer expectation. From improving product quality and streamlining processes to drone monitoring and inspection, our goal is to drive sustainable growth across businesses. Now, let's dive into today's exciting topic. Drones meet computer vision for geospatial insights. Drones, they have come a long way, and when combined with AI, they're reshaping how we approach real-time geospatial analysis. But how does this directly impact you? How can these advancements, they boost your work, your industry, and even your daily operations? So in today's session, we'll explore exactly that. You'll see how AI-powered drones are already making waves in industries like agriculture, construction, and beyond, whether it's improving the efficiency of site monitoring or enhancing precision in image analysis. Vision AI is taking drone capabilities a whole new level. We'll walk through real-world applications that show how this technology is solving challenges and pushing the boundaries of what's possible. So here's what you'll take away from today's session. How AI elevates drone capabilities for real-time geospatial insights, the advantages of leveraging AI for enhanced reliability and efficiency, the techniques to perfect object detection and labeling. We will also learn how drones are transforming surveying, site monitoring, and safety. And we will also look into the future trends, that is, we'll discover how 5G, IoT, and AR integrations will shape the future of drone operations. Let's get started by meeting our speakers for today's session. First, we're thrilled to welcome Ravi, Vice President at Marvel Geospatial Solution, as a speaker for our webinar. With 25 years of experience in the geospatial industry, Ravi has a strong background in CAD, GIS, surveying, drone technology, and BIM. As a civil engineer, he has successfully managed government projects, driving innovation in infrastructure solution. His deep expertise makes him a valuable voice in the conversation on geospatial advancement. Joining Ravi is Bhavika Patel, lead data science engineer at imagevision.ai. Bhavika brings extensive experience in machine learning, deep learning, and statistical analysis with a proven track record of developing solutions in computer vision. Welcome, Ravi and Bhavika. Ravi, the floor is yours.
Thank you, Ferlin, for setting up the agenda for the day and introduction. Before I start, let me introduce Marvel Geospatial to the participants. Marvel Geospatial is incorporated in the year 2008, and we've been successfully offering geospatial services, end-to-end geospatial services for more than 16 years. Headquartered in India, having business offices in Middle East, UK, US, we are offering geospatial services globally. Some of our offerings are listed as shown in the next slide. So when I say end-to-end solutions being offered, starting from data acquisition to data processing to delivering the final deliverable to the customers. So when it comes to surveying and data acquisition, traditionally we've been surveying using total stations, auto levels, GPS, and other engineering surveying equipments. So over the past 5 to 10 years, we've been into the drone space, and we've been extensively working with governments, state and central governments in India and also globally. So we use drones for mapping, surveying, videography, surveillance, monitoring, and complementing with GPS for geopositioning. And we're also into bathymetry and ground penetrating radars. And the acquired data will be processed using different GIS techniques. When it comes to 3D optical imagery, we use photogrammetry technique to process. When it's a LiDAR point cloud, we use LiDAR 3D mapping technology to process the data. Moving on, data conversions using GIS and CAD tools. And we also offer building information modeling, which is an engineering services. And we have been successfully offering scan to BIM services across the globe, wherein we use point cloud data to create as-built 3D models. Combining BIM with making it intelligent, we create digital twins. Moving on. Coming to today's topic, drones transforming different applications in different sectors. Before I dive into drone capabilities, traditionally, as I said, like we use total stations, theodolites, auto levels, and different surveying equipment where manpower requirement would be huge, time consuming, and not very quick turnaround. But using drones, the turnaround time is very quick. The kind of resolutions we get from drones is very high. For example, mapping started using satellite imagery, wherein today we stand at a resolution of 30 centimeter, which is available for the commercial usage. And then we have manned aircrafts, where taking permissions would take a lot of time. The process is cumbersome. So we are losing time. And the resolutions what they can provide, manned aircrafts can provide is about 5 to 7 centimeters or better. Then we have drones capable of resolutions up to 2 centimeter to 5 centimeter, where the accuracies we achieve could be twice the resolution what we have. For example, if we are getting 2 centimeter resolution, then the accuracy of XY could be 4 centimeter, and the Z accuracy what we can achieve would be around 8 centimeter. So this level of accuracies with such high resolution images, the applications of drones in different verticals have increased a lot. So starting from mapping and surveying with high precision mapping, wherein 2D and 3D mapping can be done with very minimal manpower and very quick turnaround time, to spraying and dispensing in agriculture field and delivery for medicine and food, surveillance and inspections for infrastructure, highways, mining, telecommunication sectors, and also tracking in agriculture, logistics. So applications are many. I mean, you talk about use case, we have an application of drone there. And drones are transforming the real world in a big time. So how, and when AI complements these drone capabilities, the outcomes can be unimaginable. Precisions could be very high, and the accuracies would be very great. So to talk about AI capabilities, I would hand over the stage to Bhavika.
Thanks, Ravi, for the detailed explanation on the drone capabilities in each industry and its varied categories. Definitely, there is a vast scope for the drone applications in future. So, talking about this integration of AI with drone industry, traditionally, processing high-resolution imagery and the sensor data from the drones required significant manual effort involving hours or even days of human interventions. So, a major factor driving this transformation of AI technology with drones, such as machine learning and computer vision, enable the automatic analysis of drone captured data, allowing for faster and more accurate insights, helping to reduce this manual workload by up to 80%. So these advancements are especially critical for the industries, as Ravi mentioned in the previous slide, like maintenance, surveying, and monitoring, where drones provide high-resolution images or videos of the structures, landscapes, or large-scale assets, which needs frequent inspections. With a global drone market projected to reach approx 64 billion by 2028, the demand for automated processing tools will definitely increase. More businesses are leveraging drones to capture vast amount of data, make accessibility to the high quality real-time analytics more vital than ever before. By integrating AI, we are not only enhancing the efficiency of this process, but also enable new possibilities for precision, scale, and automation in various industries. Moving on, saying that the drones powered with the AI transforming systems by significantly enhancing their autonomy, intelligence, and decision-making capabilities. One of the key areas where AI-driven drones are making a huge impact is inspections. By leveraging AI-powered computer vision, drones are able to analyze and interpret their surroundings with remarkable precision. Whether it's inspecting infrastructure like bridges or buildings, or monitoring agricultural fields for crop health. Not only this, you can see on the right, there are many different verticals where drone AI is currently at action. Live tracking of asset on construction sites, detecting defects in railway inspections, uncovering plant diseases, analyzing natural disaster damages, etc. What truly excites is that AI is helping to uncover the insights that were previously out of reach, enabling industries to optimize their processes and make data-driven decisions. The combination of this aerial imagery with AI-powered analytics is pushing the boundaries of what drones can achieve, no sooner making them an essential tool in today's technology landscape. To summarize the key benefits of the drones using Vision AI, I would say one of the most powerful aspect is ability to process and analyze this vast amount of data in real time. Drone can capture this high resolution videos frames and immediately apply AI algorithm to detect the patterns, anomalies, or defects detection, providing actionable insights without the need of post-flight processing steps. Vision AI are now equipped with advanced surveillance and detection capabilities too, so they can monitor the sensitive areas, identify potential threats, ensure robust security for both physical asset and critical infrastructure. Moving on, when it comes to train drones with the AI to detect and interact with their environment, accurate image annotations are essential. So let's look at two different key types of annotations used for targeting objects in the drone training. The one is the 2D bounding boxes. 2D bounding box annotation is one of the most commonly used method in computer vision for object detection. By simply drawing a rectangular box around the object, this annotation type is crucial for training detection algorithms to recognize and track the objects of interest during the flight, whether it is a person, vehicle, or any object of interest. This bounding box helps to identify and it also localize the position of the object in that particular environment. The polygon annotation, this kind of annotations are used to identify irregular shaped objects. As they provide a higher level of details, drones need to detect not only large, easily defined object, but also a tree, lampposts, fences, rooftops, and any other structures, as you see the leftmost picture, that doesn't fit nearly into the rectangular box. So these annotation map the precise contours of the object, offering much more detailed information than the bounding boxes or the cuboids. This allows the drone to better understand the object features, its shape, its color, so that it can detect and track. So by using this 2D bounding box for general object detection and polygon annotations for more detailed mapping, we ensure that the drones are equipped with the vision capabilities that they need, that they can handle a variety of real world challenges. Moving on. Now that we have covered the essential types of image annotations used in drone training, but how do these concepts translate into the real world application? To give us a deeper dive into this practical use cases of drone leveraging AI technology, I would like to hand it over to Ravi, who specializes in drone technology and its application. Ravi will walk us through some real world scenarios, the challenges, and the need for the AI integration with drone imagery for analytics. Over to you, Ravi.
Thank you, Bhavika. So today, the use cases which we are going to present are real pain points of the customers we've been working in India. And one of those challenges for the highway construction was to have the tree count in the green fields. So when I say greenfield or categorize highway requirements, one is having the alignment finalized using drone surveys, where the tree count plays an important role because the tree cutting has to be estimated along the alignment. So it is very important for infrastructure planning, highway construction. So when thousands of kilometers of highways have to be constructed, it is very difficult to count the number of trees or what age or size of the tree is to have the planning. Or I mean, all these highways are not located at one place, right? So when construction is happening or planned across the country at 100 different locations, it is a very huge task for a manual effort. So we use drones to have these alignments monitored using drones, videos and mapping wherever accordingly required. So we capture videos, 4K resolution videos using drones on which how the tree counting problems have been resolved using AI. Bhavika will explain you in detail.
Right. Yes, as said, tree counting may sound simple, but it plays a vital role in the road development and the planning, as mentioned by Ravi. So, accurate tree counting is essential for assessing that environmental impact of the whole construction project. So using drones, we have equipped with the computer vision algorithm. We can now capture this high resolution image of this vast area effectively. Next slide. You can see an image captured from the drone at an altitude of 50 meters in one of the Chinese. So these images are processed by advanced object detection algorithm that can accurately identify and count the trees, even in the dense or irregular landscapes. Beyond just counting, these algorithms also provided detailed information on the spatial distribution of the trees, allowing for more comprehensive environmental assessments. The following report provides the details on the tree count at the specific geolocation and the video timestamp, including the tree height, the model confidence in identifying that object as a tree, and the predicted side of the road, left or right, it would fall on within the specified range of the center line of the road. So this is how the detailed information can be gathered from an imaginary using the AI. Moving on, you will see a full-length demo video that showcases how we captured a tree data using drone. In this footage, a tree detection model is applied using the bounding box to track individual trees and ensure an accurate count, making sure no tree is counted more than once. So the model also calculates the tree height based on this predefined metrics such as this drone altitude, the size of the bounding box with other predefined parameters. By applying this measurement, we can estimate the height of each tree with impressive accuracy, typically within a margin of plus or minus 1 centimeter. Yeah, while this can also be achieved using LiDAR sensors equipped with cameras, which offer high precise data, but it can be more expensive. When near approx results can be obtained using RGB images, a lightweight AI model, and a simpler processing, this method becomes more cost-effective and efficient choice. Hence, the automation process not only speeds up the surveying phase, but also ensures a higher level of accuracy compared to the traditional manual methods. To the second use case, infrastructure inspection. Traditional methods of inspecting infrastructure can often be slow and imprecise, leading to the inefficiency and the risk of overlooking the critical issues. Recently, you might have heard about the bridge collapse due to structural defects, all that too often in every state, many states, right? So this is where the integration of drones with computer vision technology comes into play by minimizing the human error and increasing the speed of the inspections. By utilizing drones for infrastructure inspection, we can automate the entire process, making it not only faster, but also significantly more accurate. Drone capture this detailed aerial imagery of the structures, where it's pipelines, bridges, or buildings. These images are then analyzed in real time using the advanced algorithm that can detect a range of issues such as crack, corrosions, structural damages. Okay, so focusing on the left image that outlines the development phase, drones are deployed to collect the quality data on the target infrastructure, ensuring comprehensive 360-degree coverage. That captured data is then annotated, and we trained our AI model to identify any structural defects based on the label data. Once the model reaches a certain level of accuracy, it is deployed on edge or any cloud premises for real-time analysis. Upon deployment, as illustrated on the right image, new inspection images are passed through an API call to identify any kind of defects. So finally, detailed reports are generated highlighting the findings and providing visual documentation of any issues detected during the inspection. Moving on, now let's explore our third use case, progress and material monitoring. Ravi, could you take a moment to elaborate on the challenges faced in monitoring this project progress and the material monitoring?
Yeah, sure, Bhavika. So the use case 3, which again applies to highways, infrastructure, and construction sites. So material progress of construction is continuously monitored during fixed intervals. For example, a highway construction would take about 3 to 6 months to construct a certain chainage to certain chainage. So every month we capture this drone imagery, and the AI would help automate this progress monitoring. The phases of construction would have different layers of highways. In a construction site, it could be basement to number of floors, or for railway, the formation levels to track alignments, track fixing and all. So there are different stages in construction progress monitoring, and drones play a significant role in tracking this progress and also monitoring the material. Even the volumetric calculations of the materials can be done. So this is a problem statement for many construction industries in the real estate sector, as well as highway construction and railway constructions. So how this is solved using AI, Bhavika will take over.
Yes, as rightly said by Ravi, that for progress monitoring, drones capture images at regular intervals, ensure that they have up-to-date visuals of the construction sites. As always, there will be an integration of GIS with that imagery. We can ensure the spatial alignment, which is crucial for the accurate monitoring. However, even with the automation of the drones that provide, there remains a critical step. A detailed analyst must manually verify the data. This involves downloading large TIFF files, analyzing them to provide detailed insights into the project progress. While drones expedite data collection, this manual verification process can be time consuming and delaying the provision of actionable insights. So to address this, we have explored a ways to streamline the analyst workflow, such as implementing automating reporting tools and enhancing the AI models for initial assessments. So once the images are captured, they undergo a pre-processing to prepare them for the analysis. AI models are then employed to analyze the data utilizing techniques such as pixel comparison, structure detection, and calculating the structure area. This helps in identifying and quantifying the changes on the construction site over time. Since, as mentioned, construction sites progress through different stages, it's crucial to track these phases accurately. Taking the example of road construction, key stages include subgrade preparation, laying the sub base, constructing the base, following the application of asphalt layer or concrete layers. So this model can help in estimating the construction progress and then make informed decisions about the resource allocations, identifying the potential delays. So in this way, AI can be integrated in analyzing the project progress. Moving forward, here is a sample image that illustrates our AI inference on the progress monitoring on one of the drainage. In this image, you can see how the AI model not only tracks the progress made, but also provides a comprehensive report on the current status of the project. The model details the types of the structure present at this stage of construction, highlighting how much area has been covered and its GIS information. By visualizing this data, we can better understand the project trajectory and identify any areas that may require additional attention or resources. Next slide. As mentioned in previous use case, even the materials at the sites can be monitored. Analyzing the video footage, these systems can estimate the quantity of the material used across the different areas of the project. Let's break down the key components. Computer vision algorithms are employed to identify and segment different types of materials in the image using this polygon annotations. This step is essential for distinguishing between the various materials such as concrete, steel, and wood. Once the materials are classified, we calibrate these measurements obtained from the model to accurately quantify the material usage. The calibration process ensures that our estimates are reliable and reflect actual on-site consumption. To monitor this material usage over time, we utilize object tracking algorithm. This algorithm tracks the materials in the consecutive images of the video frames, allows us to assess how usage evolves throughout the construction progress. Finally, a system can generate and automate report that provide key metrics such as the type of materials reported, the quantity of the material used, the timestamp, the material usage statistics, and all. So by leveraging drone and vision AI for tracking the construction material usage and the project progress monitoring, we can significantly enhance the efficiency, resource management on the construction sites, ultimately leading to more successful project outcomes. Moving on. Now I request Ravi to address how do drones improve safety compliance monitoring in industrial or hazardous environments and what are their challenges?
Thank you, Bhavika. So while efficiency, accuracies are all very important, at the same time, safety of the personnel working on site is equally or more important. So tracking of these men at the construction sites becomes very difficult to manually do it because the area of construction is spread across large areas, and to track each individual will become very difficult manually. So drones come into picture and are very handy in monitoring these personnel, whether they are wearing their safety equipment like helmets, shoes, safety jackets, etc., eye gear, etc. So this AI can collaborate with this drone videos or images in tracking safety of the personnel. And also in case of hazardous situations, to evacuate personnel from the risky areas, drones play a very important role while able to quickly have an overview of the entire construction area and track people and plan the evacuation for each of the personnel by saving their lives. How it can be done, Bhavika will explain you in detail.
Right, as we mentioned, ensuring the safety of the worker on the construction site is a top priority. And drones equipped with computer vision system can play a vital role in monitoring safety compliance. By analyzing the real-time video feeds, the system can detect the unsafe conditions such as workers not wearing appropriate safety gears or hazardous situations. This capability allows for immediate intervention and helps ensure adhering to the safety regulations on site. Moving forward, here is how the system works. Moving on, person detection and tracking. So computer vision algorithms are used to detect and localize the individuals on the construction sites. The system draws a rectangular box around each person, assigning unique ID to track them across the video frames. This allows us to keep a count on the workers in the frame and monitor their movements effectively. The AI or the deep learning models are trained to detect whether the workers are wearing the necessary PPEs, such as helmets, safety jackets, footwears, eyewears, etc., as mentioned in the image on the slide. On any violations detected, immediate alerts can be generated for site supervisors to take quick action on them. The system can also generate reports based on analyzed data. These reports provide a key metrics such as images of the workers, the type of safety complaints detected, timestamp, and the other relevant information. This not only improves accountability, but also helps ensure the continuous monitoring and quick rectification of the safety issues. Now that we have covered how drones are being used to monitor construction sites and reduce risk on site, proceeding with our next use case on road quality monitoring. Now we will elaborate on how drones are utilized to control the road quality and why do we need to do that, and help to mitigate the various challenges that arises in maintaining consistent road conditions.
So as we have spoken some time back, when it comes to highways, we have three kinds of challenges. One, finalizing the alignment in the green fields, monitoring the road constructions in the brown fields, and once the construction is over, to maintain the quality of the highway is also very important. The periods to monitor might not be as frequent as we do it for greenfield or the under construction progress. Uh, but every quarter or every 6 months, we fly drones to monitor these already completed but are under maintenance by the contractor. So we again use images wherever required and videos over the entire stretch or route to monitor the quality of the highway. So when we use drones, we identify potholes or signages missing or the cracks developing or the markings not properly done. So all these critical elements on highway driving, which plays a major role in safety of the driver. So all these challenges can be addressed with AI integrated with the drone imagery or the drone videos, which we are capturing and providing. Bhavika?
Yes, as proven, the drone equipped with AI-driven computer vision technology are transforming the way road inspections are carried out. So this advanced system are automated the process, making it more accurate and comprehensive. So moving on, here how it works. So data collection for the first most step, where drones capture these high resolution images or the video footages of the road surface across the large areas in a fraction of time. This ensure that no part of the road is overlooked. Using vision algorithms, the system analyzes the captured data to identify these defects such as cracks, potholes, edge cracking, uneven surfaces, and other inconsistencies listed on the slide. So this detection is much more precise than the manual methods and can catch even the minor issues that might be missed by the human eye. Once defects are detected, AI system classifies them based on their type and assess their severity. This helps prioritize the repairs, ensures that the most critical issues are addressed first to maintain the road safety. The system provides real-time updates with the detailed reports highlighting the detected defects along with their location, their severity. So this allows for the faster decision making and more streamlined repair process. Moving forward, here is a demo video on identifying the potholes during one of our POC study at the highways. The system is detecting the pothole in the real time and logging its detailed information on the dashboards along with the pothole image which has been detected and what kind of how much of severity is it and at which particular location is it. So this everything will be logged. This is a real-time study video where you can see the potholes are being caught by the module. With this, moving on, I'll hand it over to Ravi, who will guide us through the future directions of drone technology and AI, along with more such innovative implementations. Ravi, over to you.
Thank you, Bhavika. So as you all witnessed, drone is making large inroads into different verticals and how it is transforming lives. Coupled with AI, what it can do, we have already seen. And in future, we'll see more transformations, more technology disruptions with drones when AI is coupled with integrated with drones. So autonomous drones equipped with advanced AI and computer vision capabilities will become increasingly autonomous, capable of navigating complex environments, performing tasks without human interventions. Enhanced sensor technology, not just optical imagery of RGB, we'll have more sensors like multispectral for agri, thermals for power lines and solar or renewable energy, and LiDAR sensors where there is a tree cover and optical imagery is not useful, are enhancing the accuracy and range of data collections by drones, enabling more detailed and reliable insights. Drones also, when integrated with AI, utilization of 5G technology for faster data transfer, lower latency, and improved real-time communication between drones and control systems. Expansion into new industries, applications of drones and AI technologies in new fields such as precision agriculture, disaster management, urban planning, and many other verticals which we've been talking about. Integrations of drones with IoT to create intelligent networks that can collect and analyze data from various sources. Augmented reality, use of AR to overlay drones collected data on real-world views, enhancing visualization and interactive analysis for various applications. And not only these listed futuristic directions in which drone is advancing, there could be many other areas where drones will be very impactful, disrupting technologies which can be used across different verticals. Over to you, Farooq.
Thanks, Bhavika and Ravi, for walking us through the incredible world of drones and computer vision for Geospatial Insight. I'm sure everyone leaving from here will leave with some great takeaways and fresh ideas. I'm also excited to let you know that this is not just the beginning. We'll be hosting more webinars in the series. We'll be focusing on the industries like oil and gas, mining, telecom, and renewable energy, where we'll also be exploring how drone technology is making waves. So keep an eye out for these upcoming sessions. There's so much more to come. Before we wrap things up, let's jump into your questions. If you haven't already, you can put them down on the Q&A box. We'll get through them as many as we can. We'll take our first question that is from Ayush. He asked, what types of AI algorithm are most suitable for enhancing real-time geospatial analysis using drones?
Yes, Pauline, I'll take this up. As there are daily advancements in the AI algorithms, so specific to the what type of algorithm, I couldn't list it out, but based on my experience, I would prefer deep learning algorithms, especially this convolution networks and YOLO for all the edge devices and all when we need to predict in real time are commonly used for the image recognition and then object detection. Additionally, reinforcement learning can also be applied to improve this drone path optimization and the decision making in dynamic environments in future. So I think this would be now, but we would look forward for the daily and whatever the advancements comes in picture.
Yeah, thanks, Bhavika. I believe that's a very common question here. I can see a lot of similar questions. Another interesting question that came in from Soman. Could you explain how drones equipped with computer vision are enhancing the farm management in agriculture? Specifically, what insights do these drones capture that traditional methods might overlook? And how can these insights practically benefit everyday agricultural operations? Yeah, Ravi, if you would like to take this.
Yeah. When it comes to agriculture, we'll have to use multispectral sensors where it can give us vegetation index to be addressed, and vegetation index will help us in crop damage assessment, crop yield estimates, crop health monitoring. Apart from this, we can also have AI integrated with drone imagery by looking at the health and what kind of disease the crop or the plant has. We can take pictures using drones, and they can be categorized, identified using image vision technologies. So drone will help them give the required input for the AI to address these issues in the agriculture field, not just crop yield estimate or crop damage assessment or crop health monitoring, but also identify what kind of disease the plants has and what could be the chemical or pesticide which can be used for that particular kind of crop. So that way, drones have the capabilities of giving the required inputs for the AI to have those models developed.
Thanks, Ravi. I hope that that answers your question, Somal. Divya has asked, what challenges do vision AI models face in outdoor geospatial scenarios like varying weather and lighting conditions?
That's a great question. Vision AI models always struggle this with the various conditions of the low lightning, glares, fogs. So to address this, thermal imaging or the multispectral sensors can be integrated, and then AI models can be trained on this diverse data set that stimulate the different weather condition. Apart from this, as Gen AI has come in picture, so we have already spoken this in our last webinar with the Gen AI, how we can stimulate the different kind of data sets, trying to stimulate this weather conditions, low lightning conditions, glare conditions to our training data set. explore that and then augment the data, our training data set so that our AI model can be adapt to this weather condition and perform with the same accuracy. So with the Gen AI, with the thermal imaging, with the new kind of image techniques from the different spectral sensors and all, we can overcome these kind of weather and low lightning conditions and still give an accurate, appropriate results with our AI.
I will add on a couple of more points to this question. So generally, when we are using drones for surveying and mapping purposes, so there are certain parameters which we follow, which includes weather, because in very high winds or bad weather, drone safety parameters doesn't really allow you to capture data. Okay, I mean, if the winds are more than 12 to 15 meters per second, then the drone will come back to the origin and we don't capture those images. And also in the cloudy conditions, where there is every possibility of clouds forming a shadow in the images, we avoid these cloudy conditions to fly. And also shadows plays a very important role when it comes to surveying and mapping. So we follow the minimum 30 degrees of sun angle when we have these drone operations for surveying and mapping. So we'll have minimum shadow obstructions when we fly between these 30 minimum 30 angle sun angle is taken into consideration. So we take all precautions not to have bad quality of images, but even in case of bad quality images, like Bhavika explained, there are Gen AI tools or models available to overcome those challenges.
Thanks, Bhavika. Thanks, Ravi. We've got a quite interesting question from Scott, and I think this one is for you, Ravi. He says that I'm based in the US, where drone regulations can be pretty strict, especially for commercial use. I'd love to hear your perspective on the regulatory challenges or restriction you face when using drones for geospatial mapping in India. How do they compare to other regions like the US?
Good question, Scott. But in the aviation segment, the rules are strict across the globe, not just in US. In aviation sector, which is the safest sector when it comes to transportation, road or rail or sea, air crashes are the least which you find across any transportation. So coming to drones, I mean, similar to aviation sector, very strict rules are implemented in India, wherein the pilots have to go through a specific syllabus prescribed by DGCA, and they have to obtain a pilot license after going through proper training. So only certified pilots are allowed to use or fly drones. In addition to that, there are guidelines which are very strict, like we cannot fly above 120 meters altitude, AGL, and there are certain speeds to be maintained. And in weather conditions, adverse weather conditions, we are not supposed to fly. And every drone which we fly has to be DGCA approved, will have a unique identification number and can be tracked. The government of India was also looking at the aspect of no permission, no fly, wherein automated flight plan has to be uploaded to the portal, and then they approve, only then the drone will take off. So this was planned to have a proper drone traffic control, but it is still to be implemented. Currently, DGCA has strictly given their guidelines in 2021 and latest a year back. And to my understanding, the regulations across the globe for drones is 80% similar, only 20% variations based on the local conditions. So more or less, drone compliance or drone regulations are quite similar in most of the countries.
Thanks, Ravi. Let's just take one last question for the day. We've just got a few minutes on the clock now. One last question from Annalise. She says she's a machine learning engineer with 2 years of experience in the field. She asked, how do you handle challenges like occlusion or overlapping objects in aerial imagery during the annotation process?
Okay, so image annotations for the overlapping objects, I won't say that 100% you can avoid it. But as I said, you can use these polygon annotations to cover the maximum part of the object, and then help that probably help to identify and separate those objects to a maximum part which is being not occluded. Or else you can try to capture it in the different angles and try to reduce this kind of occlusions, because 100% you can't avoid it with any kind of annotations. So I would say that instance segment will help you probably a bit, where it can say that this is a other object and this is other object by dividing it in a polygon way.
Thanks, Bhavika. Okay, I think that's it from there. For those of you who had actually sent out your questions and we couldn't reply to them right away, we'll do so. We'll be sending out an email and we'll be replying to your questions. So again, thank you, Bhavika and Ravi. And thank you for all who are attending today's webinar and your engaging participation. I do hope that you found the session insightful and informative. Just as I've mentioned earlier, that we'll be sending out the recording by email shortly. So feel free to revisit any part of today's discussion. If you have any more questions or you need any further information, you want to get in touch with our experts, you can reach out to us. Please don't hesitate. You can reach out to us at hello@imagevision.ai and info@marvelgeospatial.com. We're here to assist you, and we look forward to continuing this conversation. Also, please don't forget to follow us on LinkedIn, and please stay updated on the upcoming events and webinar sessions. Thanks again to all, and have a great day.